So welcome to the today's session. We'll go through this example. Here, if we go through this example, so what is there here? Three persons A, B, C are competing for the post of CEO of a company, and the probabilities of they becoming CEOs are given 0.2, 0.3, 0.4. Once they become CEO, they are going to take a policy decision because of which there is going to be a salary hike in the company. And the probabilities of they taking the decision in this direction are 0.5 by A, 0.45 by B, 0.6 by C. If you see here, we can observe conditional probability. How conditional probability involved? Here, if you see first three possible, that is A, B, C becoming CEO. Suppose if I take A1, A2, A3 are the three events where three people are competing for the post of CEOs. Now, the selection is over, then we had a new CEO. Then the next event happens, that is B, where there is a salary hike. Right? Okay. Now, if you see here, this is also a conditional probability like what we have seen in the earlier discussion. But only difference is earlier the discussion what we had A then follows B. But here A1, A2, A3, E are the events happen followed by an event B. Right? So, in that cases, what we have to do is we have to extend the discussion of conditional probability where we had Bayes theorem. Okay. Now, coming to this problem, we will see what are the probabilities given and what is that we are going to find. Now, the probabilities of A, B, C becoming CEOs are given as 0.2, 0.3, 0.4. That means here P of A1 equal to 0.2, P of A2 equal to 0.3, P of A3 equal to 0.4, right? Now, what are these 0.5, 0.45 and 0.6? That is introducing a pay hike by A when he becomes a CEO. That means if you see, and the next event already we discussed, we denoted it by B. That means this is a conditional probability, that is P of A1 happen, that is A becoming CEO and introducing a pay hike in the organization, that is 0.5. Similarly, the second one, P of the second person becoming CEO and introducing pay hike, that is 0.45. And the next one is the similar fashion, third person becoming CEO and introducing pay hike in the organization. So, these are the conditional probabilities. Now, before proceeding further, that is before finding some probabilities, these are the values already available. So, P of A1, A2, A3, P of B given A1, B given A2, B given A3 are the already known probabilities. So, these probabilities are called as priori probabilities, because we had this information before finding something, before going further. So, that is why these are called as priori probabilities. Now, coming to the probability, what we have to find is, what is the probability that there is a salary hike after having a new CEO, right? So, whether A becomes or B becomes or C becomes, so irrespective of that, what is the probability that there will be a salary hike? That means, in the simple sense, it is nothing but we want to find P of B. How to find P of B? So, here there are three cases, right? One is first one becoming CEO and taking a decision. Similarly, second one becoming CEO and taking the decision. And third case is third one becoming CEO and taking the decision, right? So, all these are three possible cases because of which this will happen. That is, I write this as, it is nothing but A1 intersection B, right? That means first one becoming CEO and introducing pay hike, or second one becoming CEO and introducing pay hike, or third one becoming CEO and introducing pay hike, right? So either in this case or in this case or in this case, we'll have the pay hike in the company. Now these are you can consider these are three events, and if you see, these three events are mutually exclusive events, because only either this happens or only one event happens. So if they are mutually exclusive, we can write this as P of A1 intersection B plus P of A2, sorry, this is intersection, this is also intersection, A2 intersection B plus P of A3 intersection B. Right? Now, from the definition of conditional probability, we know this can be written as P of B given A1 into P of A1 plus P of B given A2 into P of A2 plus P of B given A3 into P of 3. So this is what we call as total probability, right? This is what we call as total probability that there is a pay hike in the organization. Now we can plug in the values. So where we had P of B given A1 as 0.5 and P of A1 is 0.2 and this is 0.45 and this is 0.3 and this is 0.6 and this is 0.4. So if we simplify, we will get the total probability of happening of the event, that is there is a pay hike in the company after having new CEO. Right? Now we have seen the total probability, right? Now what I do is I will modify this question. Right? Now there is a pay hike in the salary. Right? There is a pay hike, that is already people are getting salary hike. What is the probability that this is because of A becoming CEO? Right? So now we are changing the question where already the event happened, somebody became CEO and they took the decision of increasing the salary. So what is the probability that this salary hike happened because of A? Right? So then how to find? Now we'll see this representation. Now this is the first event, that is A becoming CEO. So with the probability 0.2. Next event follows is he taking a decision related to salary hike. That is, if you remember the discussion what we had, the first event happened followed by B. So corresponding probability is 0.5. Now similarly, the second person becoming CEO with the probability 0.3 and he taking a decision, that is A2 followed by B with the probability 0.45, and third one A3, third person becoming CEO with the probability 0.4 and he taking the decision related to salary hike, that is A3 followed by B with probability 0.6. Okay. And if you remember the previous discussion what we had, the total probability we can find, that is probability of B, that is P of B given A1 into P of A1 plus P of B given A2 into P of A2 plus P of B given A3 into P of 3. This is what we already discussed. This is called as total probability. Or simply we can write this as summation I equal to 1 to 3 P of B given AI into P of AI. Now what is the probability we have to find here? That is probability of having a pay hike, that is B happened. Then what is the probability that it is because of the first person becoming CEO, right? So this is what we have to find, right? So I repeat here if you want. So here we had a new CEO, then we had new policy, that is salary hike. What is the probability that is because of A becoming CEO? Right? So this is what we, now you can similar to what that is discussion what we had, try to differentiate between B given A1 and A1 given B, right? Once it is clear, then we can solve this problem. Now, by using the basic definition of conditional probability, this we can write as P of A1 intersection B by P of B. And as discussed, P of A1 intersection B can be written as P of B given A1 into P of A1 by the total probability P of B, already what we had, this summation I equal to 1 to 3 P of B given AI into P of AI. So now if you see here, we can use this diagrammatic approach to find probabilities of this kind, where this approach comes under Bayes' theorem. So in each case, what we have to do is we have to find the total probabilities, like what we have done earlier. Now that is, here total probability comes into picture, right? Then what about the numerator? Numerator here, this is the one which is in favor of the event what we are looking for, that is the salary hike because of A becoming CEO. That means this is the favorable case out of all the three cases. Therefore, this comes into numerator. Suppose if we want to find the same with respect to B becoming CEO, then numerator is represented by this P of B given A2 into P of A2. Similarly, if we want, we can find it with respect to the third person becoming CEO, right? So this is the approach where we can solve problems of this kind, where this is nothing but Bayes' theorem, right? Now, what is Bayes' theorem? What is the statement of Bayes' theorem? Suppose if A1, A2, A3 and so on, An are mutually exclusive and exhaustive events, and B is an event which follows, then P of AI given B is equal to P of B given AI into P of AI by the total probability, that is summation I equal to 1 to n P of B given AI into P of I. This is the statement of Bayes' theorem. What I suggest is better to have this approach to solve any given problem related to Bayes' theorem, for which what we have to do is we have to identify the events first happens A1, A2, A3, then next and corresponding conditional probabilities. Then what we have to do is we have to calculate the total probabilities, here the total probabilities. How to find the total probabilities? Now sum of this into this plus this into this plus this into this gives the total probability. Then depending on the problem, suppose if it is related to for example in this case related to first person, then this becomes numerator. Otherwise, in case of second one, this becomes numerator. If it is third case, this becomes the numerator. Like this, we have to apply Bayes' theorem to solve problems of this kind. Thank you.